Hello class, this is part 2 to this chapter of pressure, and for part 2 we're going to talk about pressure in liquids. Imagine swimming in a deep tank. Which depth of water would you feel has the highest pressure? So let's say this is the tank. At which point is the pressure highest? Is it point A where it's at the surface, at point B where it's in the middle, or at point C at the bottom of the tank? The strength of the pressure in a liquid can be demonstrated by means of a tall vessel full of water with side tubes fitted at different lengths. Or you can just use a water bottle and just punch a few holes on the water bottle. Now, if you do this, you will see from this picture here, the water that's coming out of the top hole doesn't go very far. And the water that is coming out from the bottom hole, the lowest hole, shoots out the furthest. This suggests that the water at the bottom has the highest pressure. So, going back to this tank again, at which point is the pressure the highest? Depth C has the highest pressure. The pressure inside a volume of a liquid depends on the depth below the surface of the liquid. So the deeper it is, the greater the pressure. So why does the pressure increase in liquids the deeper you go? This is because a liquid exerts pressure due to its weight. So the deeper it is, the greater the weight of the overlying liquid and the greater the pressure. So what is the overlying liquid? Let's say you are at point C and all the liquid on top of you, that is what we call the overlying liquid. And all that liquid on top of you exerts a force on you at point C. So all that weight is pushing down on you. Let's say at this depth, all the weight of the liquid on top of point C is 100 newtons. So that's how heavy or how much force that mass of liquid exerts at point C. So if you go deeper, now you have more liquid on top of you. There is more overlying liquid. And because there's more liquid on top of you, that mass of liquid has more weight and exerts more pressure. That's why the deeper you go, the more liquid that's on top of you, and therefore all of that liquid pushes down on you and exerts a great amount of pressure. And in this case, the weight of liquid is 500 newtons more than the previous depth. So the pressure of liquid comes from the weight of liquid on top of a certain point. Now, how does this affect the real world? So a dam must be designed to be thicker at the bottom than at the top, since the pressure at the bottom of the lake or at the bottom of the river is higher. Therefore, the wall has to be thicker at the bottom than at the top. Now, when divers go to the bottom of the sea, they need special underwater suits to survive the great pressure of the ocean. So really deep divers need suits made out of metal or even submarines in order to survive. So you can even feel the water pressure when you go swimming. When you are at the surface of the water, you don't feel a lot of pressure. But as you go to the bottom of the pool or to the bottom of the ocean, you can certainly feel the pressure that is exerted all around you. So to summarize part 2, you need to understand where liquid pressure comes from. Liquid pressure comes from the weight of the liquid column on top of a certain point. So if you have more liquid on top of you, so if you go deeper, there is more liquid on top of you, and therefore a greater pressure is exerted on you. And you need to know also that the pressure beneath the surface of a liquid changes with depth. So if you go deeper, that means there is higher pressure. Okay. The next part of our video lessons, we're going to look at how to calculate liquid pressure.